My name is Caleb Bills, and today, Mark, Christian, and myself will be discussing 3 different topics that relate to our experiment as a whole. Our experiment is entitled, Saving Polly Pocket.
I'm going to talk about inertia. The textbook definition is, every object continues in its state of rest or of uniform motion in a straight line unless it is compelled to change that state by forces impressed upon it. Yeah, I didn't think many of you guys would understand that. So, inertia, think of like laziness. Okay, not that kind of laziness, but pretty close to it. Like here in my hand I have a block. And it's like in a pretty still state. It's not moving. Not moving at all. Until another force comes, hits it, and then moves. So now that state of inertia is in motion. And it stays in constant motion until another force acts upon it, like gravity. For example, we have a car that is just parked on the street. It's in a state of inertia. There are no forces acting upon it until let's say another car comes and rear ends it. As you can see, that's an example of inertia.
So we get it? I'm gonna get it.
We'll be starting our energy transfer machine with the concept of a tether ball.
So we get it? I'm gonna get it.
You see, a tether ball in motion has energy that wants to move straight forward or tangent to the circular path it's already on. The one thing that's preventing the ball from actually escaping the circle is this string right here. If we were to cut the string, then the ball would no longer travel in the circle and instead straight forward. In our case, however, we aren't cutting the string, but instead transferring the tangent energy into a separate marble through contact. We put it in the pathway, and by doing so, we hit this marble and set it on a different path down to the second half of our machine.
I'ma get it. I'ma get it.
I know you came here to see. If you a freak, then you
An object may store energy because of its position relative to another object. This energy is known as potential energy because in the stored state it has potential to do work. The formula for potential energy is the object's height above the ground times its weight. Moving on, if an object is moving, then by virtue of that motion, it is capable of doing work. We call energy of motion kinetic energy. The formula for kinetic energy is 1/2 mass times speed squared. This block is at a certain height above the ground. Right now, because it is not in a state of motion, it has a certain amount of potential energy. We would take the weight of this block and we would measure the distance from here down to the ground. That would be the potential energy that this block has. Now, as soon as I drop this block, that potential energy changes to kinetic energy.
it's going down for real.
Now that we have explained the scientific principles behind our experiment, we can continue to our mission to save Polly Pocket.
Yes, I be a woman. Yes, I be a baby. Yes, I be whatever.
A marble is attached to a string. That marble will unwind and will collide and transfer its energy into the marble that is in a state of inertia. That marble will roll through the track, transfer its energy into the blocks that are in a state of inertia. Then the blocks will dislodge the string, allowing the Polly Pocket toy to crash to the floor, releasing its energy through the impact with the floor. The marble traveled at 5.49 feet per second, or 65.964 inches per second. The total track length was 188 inches. The mass of the Polly Pocket toy was 13.8 grams. The mass of the first marble spinning was 23.1 grams, and the mass of the second marble was 3.7 grams. The Polly Pocket's potential energy was 345 joules. She fell 25 inches in 0.6 seconds.
Yes, I do the cooking. Yes, I do the cleaning. Plus, I keep the nana real sweet.
It looks like that's a wrap. Thank you for watching our video on energy transfer.
I'm not trying to be rude, but hey, pretty girl, I'm feeling you. The way you do the things you do reminds me of my Lexus cool. That's why I'm all up in your grill, trying to get you to
Components.
Wait.
Caleb.
I'll show you how it works.
So baby, give me that.
Go back.
I like how he walks out.
I know. Don't move. Just stay right there.
Part. It's just part. And
Wait, start over.
They store energy because of its position relative to.
for example, we have this. I'm getting so mad, dude.
Alright.
Bounce, bounce, bounce. Come on. Now it's like murder, she wrote.